Okay, hello everyone. I'm Suprakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Today I'll take the assignment number 8 live session, which is related to the interfacing of the PV panel to the battery and load. There are two types of load connection, or you can connect the load through the battery, or you can connect the battery directly to the PV panel. And battery connection also depend, although direct connected, or it used a controller to charge the battery, to charge control. Connection of the battery, there are two types, by controller or direct control, such as PV to battery connection. One direct controller, second one through the charger. Direct control means you control the solar PV directly to a battery. But if you want to connect this one, so battery should be in practical, like it has some internal resistance, because if it is the ideal, then you can be connect two voltage source in parallel at different voltages. PV panel have a different voltage at a different isolation. That's why you can connect directly to the battery, ideal battery, but the ideal voltage is not in the real frame. That's why it's a battery with an internal resistance. You can connect them to control the circulation current between the battery and PV panel. Sorry. There are two modes of charging and discharging. Charging mode, current in that connects VV, battery voltage, will VT minus of I into RB. This will be internal resistance of battery. And discharging condition, discharging means it will supply to the load. Battery is supply to the load. In that condition, the terminal voltage, yeah, I can say this one, load voltage plus IV into RV. So the battery charger, it means charger charger control between the solar panel and battery. This is actually DC-DC converter work as a battery charger. This is the battery. If you want to take internal resistance, this is the internal resistance. But in direct connection, it have a problem of a specification of the solar PV. All of you know about the IV characteristic of a solar PV panel, a solar PV. It is like that. This is the current, this is the voltage. This is open circuit voltage, and this is the short circuit current. If a battery, if you have a battery, so battery terminal voltage is between the 0 to VOC of the solar panel voltage. It should be. Then you can connect the battery directly to the solar. It means that if a VOC, it means battery voltage should be lesser than the VOC of the PV, not equal to, also less than the solar PV open circuit voltage. But you can't be sure that it will work in the MPPT mode or not. It will transfer maximum power or not, because of the battery voltage is fixed. If you connect the battery terminal of the solar panel, it means the output voltage it fixed. You can't be vary the output voltage. Then voltage, with respect to the voltage, current will flow through the by the solar panel according to the insulation. So if you have some voltage, battery voltage PV, a terminal the rated nominal voltage like that. But if you charge this one, even if you charge this one, the terminal voltage of the battery will increase because of the internal resistance. This one, then that is the operating point. This is the voltage because of the IB into I ray, internal resistance. If the load profile of the battery is matched to the PV panel, then you can connect the battery directly through the panel. But if your characteristics is not matched, then you can't be connected. In that case, you should you must be require of the DC-DC converter or charger. Then the second point, the voltage profile is different or not in range of the solar panel. Is the overall view of connection of the battery, so to solar directly or using a DC-DC converter. Then I will starting taking the question. Like a boost converter is used to charge a battery. It means converter is a charge converter is connected between the battery and the solar in a current control manner. Current control means a boost converter, a buck converter, any converter, you can control the voltage, output voltage in a expression of the duty cycle. But if you connect the battery the to the converter, it means your voltage is fixed. Then you can't be change the voltage. In that case, You only change the current if you increase the duty ratio or decrease duty ratio in terms of the increase the terminal voltage, output voltage of a converter. In that case, the current will be increased because of the voltage difference between output to the battery is be different or increase. The voltage difference increase, then current will be increased. That's why here the boost converter, any converter used to charge the battery in a current control manner. It is another other advantage also. Suppose you have, if you have a battery, voltage versus SOC. If you draw a characteristic between SOC to the zero SOC, it is profile like that. It will be at 100%, at 0%. Between 80 to 20%, it will profile the prox constant, not approx linear constant. You get 20% to 80% by any battery. It means if you fully charge like 80% and 90% of battery, and that condition, battery chemical reaction shows that the voltage will build up a voltage very high in terms of the terminal voltage, a real terminal voltage, because of the chemical reaction, chemical equalization. It shows the higher voltage at than the actual voltage. It means if you have a 12-volt battery, like if you for example, if you have a 12-volt battery, if you charge this one the from a current of like a 5 ampere, internal resistance of, suppose the internal resistance is like 0.5 ohm, then what is the terminal voltage Vt? 12 plus Ib in at a charging time, Ib into Ra, it will be 12 plus 5 into 0.5, it will be 14.5, it will show a 40.5. At that case, if you disconnect the battery from charger, then it will show only 12 volt like that, because of the current is 0. If the current is 0, this one 0, then the drop is 0, the battery charge is 12 volt only, but it shows the terminal voltage is 14.5 volt because of the internal resistance and higher current rating. That's why I think you listen about the charging of the battery is a constant voltage and constant current charger. In that case, if your battery charges a 90 to 80 to 90% charger, in in that case you should decrease the current of your current, decrease your current at minimum point to charge the battery, and it means you charge the battery at slowly condition, slowly, not a higher rating rate of charge. In that case, the voltage drop of internal on the internal resistance is very less. In that case, the Vt terminal voltage is so is original or approx the original or real. Sometime if you set the battery voltage cutoff point like 14 volt only, Vt cutoff point. Suppose you set the cutoff point in the charger, if 14 volt. In that case, battery also discharge. In that case, if you or battery terminal voltage goes beyond the 14 volt, the connection will be disconnect. Charging will be stopped, but your battery is not fully charged at that time. In that case, you should decrease the current at a minimum level like 1 ampere or 1.5 ampere, to charge the battery, slowly charge the battery, then that time the board battery is fully charged. The error will be minimized. This phenomena occurs in same as then the PV panel. Suppose this is the in a rest, it means dischargeable battery. The terminal voltage is this one. If you charge the battery from here to like here, you can see the battery voltage will be increased some point like here. This will be, I take a VB1. In that case, if you take a charging line, operating point is this one. This one is very reduced current. Current will be reduced at that point. It means if you goes through the fully charged battery or to 100% SOC towards 100% SOC, the battery voltage is increased, the current will be decreases. In case of solar panel, current will be decreases. That's why this is the perfect charger for the battery in direct connection. If a battery is arranged between the solar panel, current will be reduced. In that time, current will reduce and the error will be minimized between the actual voltage of battery voltage to the terminal voltage. Same thing. Okay, take the question. The boost converter, that's why current control is applied, because of current control at fully towards the fully charge like 80 to 90% decrease the current. Any charge controller. The boost converter is being supplied by a 36-volt PV sources. On the connection of this one, the boost converter is the switch, diode, capacitor. This will be the battery. This one VT, this one IT, same as the IL. This one IB. At a charging condition, should operate the switch. This one Q switch at MPPT also. Taking this one ITVT and apply the algorithm. After that, it generate the duty cycle. Give to the MOSFET driver. The boost converter being supplied by 36 volt. The VT is 36 volt source. The battery has a nominal voltage of 60 volt. The boost converter uses a MOSFET, power semiconductor switch. Okay, the frequency is the 50 kilohertz. The boost converter uses a 4 millihenry inductor with a maximum current of 3 ampere. A slope in the current reference expressed in volt per millihenry each. In the charge, in the current control mode of any converter, the reference current will be set as like the in disturbance condition it will be reliable. It will work reliable in disturbance also. I'll give you the overview of this one. This one IT same as the IL reference. The current control IL reference. So now IL reference is set by the MPPT algorithm. Yeah, you can give the reference as you wish. Like in a starting condition is a charging as 0 SOC or lesser SOC, then give the full current, and after the reaching towards the 100% SOC, like 80 to 90% to decrease the current rating. That's why IL reference. This one IL with the inductor current. Oh, sorry, you will be passing through a comparator. Positive connected to the ground and negative. This is the and a SR flip flop is used to generate the duty cycle, and this is the duty cycle D is connected to the MOSFET. Sorry. S is connected to the clock. I think all of you know about the SR flip flop. I written two table. I write this SR, where the S is set, R is reset. If S is high, it means it will set. It means trigger the value, higher value, and this is the R is high. It means reset value high. It means duty cycle is 0. Like here Q, if S is high and R is 0, then Q is high, duty cycle on, and when the S is 0, R is high. It means reset is high, then duty cycle will be 0. Simple fun, simple thing. I have a SR flip flop. These are two switches SR. It means there is the 4 state 0 1 1 0 1 1. 0 0 is there. That means a Q has no change. The same value means the previous value. If R is reset, R is high, it means Q is 0. This is the reset. Hence S is high, then this will be high, Q is 1. At time it means a set. This is the no change. And no change, it means the previous value is output. Clock plus is trigger after one cycle. This is a clock. This is set by the frequency, like frequency. And the inductor current will be rippled as a lower to higher value, higher to lower value, like that. And reference point always set the higher value. This one is the higher. If you take IL as a reference, this one, this value, then what will the Q? Yeah, same as the duty cycle. When is high? Looks very if IL is a high, IL reference in this condition. IL is less than up IL reference in that position. IL, this one is less than, it means this is a positive, this is positive, it means negative value is greater than the positive value. And that means the minus VCC comes out the through to the reset. It means the reset is high. One second. Okay. Listen, if this one is the positive, it means it will be greater than 0. Positive connected to the 0. It means negative connected to the positive. It is minus of VCC come out of employment is there, minus VCC. It means this one. The reset value is 0. It means negative. It means 0. Then set is high because of the clock here. R is 0. If R is 0 and S is high, and that condition the set is there, it means this will be turn on. Q is high. Q is high till this will is here the previous value. R is 0 because of this one, the negative value of this one. R is 0. Set is only one times because of the clock is high, it means set is high. If clock is 0 here, remaining time 0, it means the previous value is maintained till the next state. So maintain duty cycle high here. After this one, if I there is the IL is greater than IL reference, IL is greater than, this means a negative value. It means here is the negative value. Negative value means this is the positive is the higher the negative value. The plus VCC is out. Put up this one. That means reset is on. And reset is on. It means reset is on. Then Q is 0. At that time, this will be 0. It will work like that. Current control method. But sometime if a disturbance occurs, if you fix this one, IL is fixed, and disturbance occur, IL duty cycle will be changed lower to higher, then that time the system maybe goes to unstable. To protect this one, it will use it to use of the slope compensation, current slope compensation method. In current slope compensation, suppose you have this one. I will between in range charging and discharging like that. Disturbance, if disturbance occurs, then if current will change because of the load is changed, and this will be goes beyond the 2 cycle will increase. Then this is the cycle of clock cycle frequency time period. It will go here only. After this will be increased. and that time this is previous value, not the previous value. This will become thoroughly to till 0 or some minimum value till the next state is on, not come. After that, this will be disturbance is very high, more and more. If once disturbances occur, then you will can't be controlled this one because of the flip flop. SR flip flop is there. This is one state. This one is the clock as at the time period state. This one next state. Here is a here is a set value. This is a reset value, and between then it will go because of the previous value maintained between here to here in this period, in this period, in this period. Previous value maintained. That's why if disturbances occur, then this will be duty cycle will change because of the to control the IL reference. IL is changed, then ripple is also changed, but your IL is fixed. IL reference is fixed, but due to cycle is changed, then current will be slope is be like that. After this one to reach the IL reference, it will be triggered as a reset value. Then it will be 0. Switch is off. Then current will be reduced till reduced. Then next clock is not on. But here is a time period time. This one state it means the clock is high. Then duty cycle increase, but and sometimes after very few second millisecond, and this will be reached at a IL reference also, and that time this will be reset value on, then duty cycle is 0 here only. In that case this will be follow the same path till the next cycle is next reset is not come will not come. That's why this difference will be increased more increased. To compensate this one, another method is slope compensation. Is doing is this one is the control the up slope. It means turn up slope in that manner, and to set the IL reference like that. 0 to T time period, it will follow like that. This was the IL reference. To avoid this phenomena, we'll set that like a sawtooth waveform. IL is set like a sawtooth waveform, but IL reference is generated by the decreasing slope, or when turn off the switches, and that time the IL slope is taken for generate the IL reference in sawtooth waveform, like sawtooth waveform. In the in that you can observe this one. If a disturbance is occur, then this will be goes here only. This is IL reference. Can't be more than IL can't be more than the IL reference. If the reset value is on, it means the reset it will due to 0. Then suddenly it will follow the previous value, and it will be controllable very quickly. Because of this slope is the turn up slope, our decreasing of the IL current slope. And that means it will ask about the boost converter, the slope in the current reference express. It asking about the slope, that slope is taken, that slope it will which one is the decreasing order of a IL. It means the switch is off. Like when Q is off, and that condition, this is the KVL. and Q is off, this will 0, due to diode is high, then this will be flow KVL like that, a circuit, closed circuit maintain like that. In that case you can apply the KVL. This is a plus, is minus of Vt, plus of VL, and this is the plus of Vb, battery voltage is equal to 0. Then VL is Vb plus of Vt, oh sorry, Vt minus of Vb. Okay. VL can, you know about the, it will be written as the DIL by dt. LDIL by dt is VL, inductor voltage. This is the Vt minus of Vb, write in here, LDIL by dt is equal to Vt minus of Vb, then DIL by dt is Vt minus Vb divided by FL. This is the slope, a decreasing slope. Why decreasing? Because of the Vt is lesser than the Vb. It is the boost converter. Then output voltage is greater than the input voltage. Then this slope will be negative. Put the value. This will look. This is the voltage, and this is the inductor. Then you can say that this one the voltage V by inductor Henry, and it is also known as the IL. This is the current. This is the time, ampere per second. You can also say that. But this question is asking about volts per millihenry. It's the same as the volts per millihenry, means you can put the value here. Vt, terminal voltage 36, Vb is 60 volt. 36 minus 60 divided of inductor is 4 millihenry. Is asking us the volt per millihenry, means this one is the 6 millihenry, 6 volt per millihenry, minus of 6 volt. This is decreasing at slope. This is set as the IL reference, because of same as this is the same as the 6 ampere per second also. Okay. The next question. A solar energy installation uses three-phase line communicated flow bridge converter to feed energy into power system through the transformer of a charge 400 to 400 as shown below. The energy is collected from PV array in a bank of 400 battery and is connected to converter through a large filter of choke resistance of 10 ohm. Then the maximum current through the battery will be. This is the current flow like here to here, because of this was the three-phase solar system. Solar energy installation, there is some solar panel to charge the battery. When this battery is charged, then this charged battery is fed the power through the to the grid. This is the grid through a transformer and converter. This is the converter is same as this is the inverter. If you charge the battery from here to here, this will work like a converter, like this rectifier, and when you feed the power from battery to the grid, it will work like an inverter. Then it is say that the maximum current through the battery will be maximum current. Maximum current flow, when is maximum current flow? When this output is 0 in some time, because of the sinusoidal, there is some waveform where passing through the 0. At point of 0, that time maximum current flow, because of the this is the circuit is complete, like 0 is the 0, there is a 0 and battery is only present. That's why when we talk about the maximum current, it will be on VB minus this one the three phase voltage, and this will be 0. That time the maximum current will flow IM, and VB is 400 divided by of current, this resistance of 10 ohm, this will be 40 ampere. Now this is the fading the sources the power to the grid through the transformer. This is the DC current, maximum DC current. You can see also because of flowing through the battery. The 40 ampere. Okay, same question is asking the solar energy installation uses three-phase line communicators converter is fed through the input power system through a transformer 400 to 400 volt. As on below, the energy is collected from PV array in a bank of 400 volt battery and is connected to through that large filter choke resistance of 10 ohm. Same thing is given the KVA rating of the input transformer. This one, what is the KVA rating? First of all, what is the KVA rating of any transformer? KVA rating of transformer, know about root 3 B RMS line VL line RMS into IL line RMS, root 3 V into I, and power, three phase power, all of you know about three phase power, root 3 V into Y into cos phi. If a power factor is not considered, then that power is a kVA. This is the kilowatt, this is the kVA. Then line voltage is given as 400 volt, but what is the line current? I think all of you know about the inverter line current is RMS current, the I naught root 3 by 2, root 2 by 3. In 120, there are two types of mode, 120-degree mode or 90-degree mode inverter. In 180-degree, the one phase work in 120-degree. After that, it's only 0. Next waveform is occurs 120, 120, 120-degree. It will conduct it one phase, second phase, third phase. That's why it will be root 3, root 2 by 3, 120 divided by 180. I naught is I have connected. I calculated is 40 ampere in previous questions, and root 2 by 3 it will point, I think 0.812 something. Is the RMS current in input side, like here. This is the I naught, maximum I naught, and that time that's this size, this side is IL RMS. This is the IL RMS current, and 120 mode, 180 mode. If you know about the inverter input current, this was 8164 IL RMS is into 40 ampere. This is the 32.659 ampere. Then this is the 32.659. Then what is the kVA rating of transformer? current into voltage into root 3. This is the 22,627 22.62 kVA. This is the third option. This is the second option. Decide the kV rating of transformer. The following circuitry can be used in battery charge controller to reduce the chattering and proper operation of the mechanical relays used for switching. Which of the following will be the correct transfer characteristic of the circuit? It means the output voltage versus input current. Input voltage. Output voltage versus input voltage. So this one A, B, C, D. The circuit is given. If you observe this one, only this circuit, op amp. It is same as look like a Smith trigger. Smith trigger have a positive feedback and negative of the op amp is connected through the input voltage. This is the Smith trigger, but this one is not a Smith trigger. This is the negative feedback. If negative feedback is there, it means there is some. It's any other information is not given related to the op amp. Then you can assume this one is the ideal op amp, and ideal op amp the input impedance is very high, and any op amp input side is we have like a voltmeter, and output side we have like a voltage source in voltage amplifier. Then the input impedance is very high in ideal cases. It is very high. That's why the current will be zero. Input current will be zero in both the side. In that case, you can take a virtual short. It means this voltage is same as this voltage. When the negative feedback must be there. This is the negative feedback. The negative terminal is given by the feedback. But here is the positive feedback. This way that circuit is work like a Smith trigger. But this was not a Smith trigger. This was a normal op amp like subtractor. And that's the side you can use. This one is the virtual short. This means that this voltage is same as this voltage. I'd rather differ both circuit at different time. First of all, I drive this circuit and find the output of this one. This is the output. I'll take it V output 1, and after that I will take this circuit Smith trigger. How this one will work and how will this will work, and what is the output voltage. So all of the same resistance, R. Here I'll take it, this one is the VA, this one I take it VB. The V in between this one, I can take this one is the VA, this one take as a VB, then VA minus VB is V in. Because of this one is the positive, because arrow is there, here is arrow, this that terminal is positive, this is negative, and VB minus VA minus VB is V in. That's why I've taken as a different VA and VB. Then because of the virtual short, I said this voltage is same as this voltage. If you take this one, current will be 0 because of the ideal op-amp input impedance is very high, current will not flow through the input side. That's why the same current flow like that. Then what is the this voltage? Or and this is the ground. It means this is the voltage divider VB by 2. Because of two resistances connected in series, this will connect 0, it means both are connected in series and it has same value. Then between one resistance voltage is half of this one, V by 2. If this is the 0, this is also 0, this is the 0 current. In op-amp, in negative feedback, the virtual short is there. That's why this voltage is same as this voltage, VB by 2 also. Then what is the current? This current is 0, input side, then this current is same flow through there. Then you can find by KCL at this node, VA minus VB by 2 divided by f R is equal to same as this current VB by 2 minus of V naught 1 divided by of R. Or cancel out, VA minus VB by 2 is equal to VB by 2 minus of V naught 1. VA, we take this one is the VB equal to minus V naught 1. VA minus VB, this one is V in. VA minus VB is equal to V in, given in the question. That's why VA VB is V in is equal to minus of V naught 1. Then you can say the output voltage of first op-amp is minus of V in. Is an inverter, like it work like an inverter. Which one is you give the input side, the output will be same in opposite side. Okay, one circuit is complete. It means this is the same as the minus of V in. I have taken this Smith taker and how it will work. So I give you like a V in here. Sorry, V not 1, I give V not 1. This is the VCC plus VCC. This one is the minus VCC. This is the output voltage, V output. I take this one voltage as a V reference. What is the V reference? By this one, same thing, current will be not flow here because of the higher impedance. Then both our resistances are connected in series. Then what is the V reference? Same as V reference is V output into this resistance R divided by total resistance R plus R, half of this one, V output divided by 2. And इसमें trigger, note the point, this is the input voltage. Input voltage is connected always in negative point and reference voltage generated in first terminal of the op-amp. If V naught 1 is greater than V reference, it means this voltage is greater than this voltage. V naught 1, this voltage is greater than this voltage, it means a negative voltage is higher. If a negative voltage is higher, then output will be goes to minus of set value, the saturation value. In that case, output is minus of V saturation. The saturation limit is a VCC or minus VCC. This is the saturation limit. It means a minus VCC is come through the output because of this one negative terminal is higher. When negative terminal is higher and positive terminal is lower, then the minus VCC is come out the output. Same if V out 01 input voltage in here is less than the reference voltage. It means this voltage is more negative to this voltage, the input voltage. In that condition, take the minus of V reference because of this one negative, this is negative value, this is a more negative through this one. It means V naught 1, the input voltage is more negative this one, and that condition this will be the higher potential. This is a higher potential, the positive terminal is higher of op-amp, then plus VCC come out the on the output, plus V saturation and plus of VCC. The first I'll find the reference value. In the given question, VCC is given as 12 volt. Then output is the plus VCC or minus VCC. Then minus VCC is minus 12 volt. Then reference value, what is the reference value? V reference. VCC is come out the output are positive or negative. If this one is the negative, then minus of VCC come out, and if this one is the positive, then V reference is 12 divided by 2 of 6 volt, and minus V reference is minus of 6 volt. This is the limit reference value, or this you can say this one is the saturation value or hysteresis band of this one. V reference minus V reference to plus V reference. It means Smith trigger is to work between the minus V reference to plus V reference. It is minus 6 volt to plus 6 volt. This is your set value of the hysteresis band of Smith trigger. And output will come either positive plus 12 volt or negative minus of 12 volt. According to V negative, V not 1. This is V not 1. This is the output voltage. V naught 1 is set as the reference as minus 6 volt and plus 6 volt. The hysteresis band. This is the minus of 6 volt. This is the plus of 6 volt. Okay, take this one. Your V reference is negative. It was a minus of 6 volt. It means this is the V minus of V reference. This is the positive of V reference. Then V naught is more negative to minus V reference. In that condition, you can observe this one. V output is more negative to V reference, minus of V reference. It means V output is here in that zone. The output in that condition, output is the plus of VCC. When V naught 1 or input voltage of Smith trigger is more negative to the reference point or hysteresis band point, and that condition output voltage of Smith trigger is plus VCC. It is plus VCC comes from the output. This is the plus VCC. It means that VCC is 12 volt, minus of 12 volt. This is same. This is the VCC. This is the minus VCC. When the V output in V naught 1, it means input voltage of Smith trigger is more negative to the reference point, the output voltage is the plus VCC. It means this is that till this is the till, then the next plus VCC plus V reference is not come. And next is this one V output if greater than V reference. It means in positive direction, V output is our input voltage. Sorry, V naught 1 is the input voltage of a Smith trigger. Then input voltage of Smith trigger is more than the reference value. In that case, the output voltage is negative. It will be till positive when the 6 plus of 6 volt is not come. This is after the 6 volt. This will be a negative of 12 volt. After V reference is 66 volt. This will is the this is the input voltage of a Smith trigger. Smith trigger is more than the V reference value. The output is the minus of VCC. That's why this is the output. This line. This is the output line. When V reference or this is the input of a Smith trigger. Input of Smith trigger is more than the plus 6 volt. The output of the Smith trigger is minus of VCC. This is the minus of VCC. This is the line, straight line. Okay. Next one. You can say if you come from a positive side, this one, when V output is more than the V in reference, the voltage is negative, negative, negative till the next minus VCC is not comes. This value is this one's this side like that. When input voltage by minus to positive, this one, and input voltage is negative to positive to negative like that, then output comes like that. This is the hysteresis band here to here, and this both signal is the output signal of Smith trigger. When it comes from out from positive to 0 and negative, like if suppose if you take a sinusoidal signal, this is the positive 0 to positive maximum and negative 0 to negative. After that, you from negative to 0. This is the positive slope. This is the negative slope. same as this one. This is the negative to positive. This is the negative to positive. It means this side's absolute. This is the positive to negative. It means this side absolute. It will behave like a hysteresis band. It will be between the V reference to minus V reference. Same if you take this one is the V output one or this one is the V input. You can give the any input of in place of the V input. Any signal, sinusoidal, square wave, anything. If this is the in that nature, in here is the both positive and negative cycle. Then the output of the hysteresis band, output of the Smith trigger is a hysteresis band lie between the plus V0 reference to minus V reference. V reference is the feedback voltage of the positive feedback voltage of the op amp. Okay, comes on the questions. Or the question says, this one is the question. I will take a V output 1 as the input of the Smith trigger, but V output 1 is the negative of the V in our question. If a negative is not there, this negative is not there, then this is the answer. This is your answer of that of this question. But V not 1, you can say the V in is equal to minus of V not 1. Then same graph is revert. Same thing, but in revert direction. Revert this one. All the reference point will be same, output will be same, but graph will be reversible. So plus 12 volt is the output. This was V in minus of 12 volt. This was minus of 6 volt plus of 6 volt. Then graph will be like that. Because in our question, this is the difference. V in is the negative of V not 1. Then this graph is correct. This one graph is correct. Yeah, these both are matching. But this one is the when V in is V. This is the V output 1. If you take V output 1, V in is positive, then this will be correct. But V in is the negative of V not 1 is equal to minus of V not 1. That's why this will be correct. D option is correct. This is not correct because of the Smith trigger. If same thing, this is the positive. If in the question it will given this is positive, this is negative. Same op amp. If that what is given, then A or B is the option, is the answer. But here the negative feedback is not there. Positive feedback is there. Positive feedback it means this is the Smith trigger. The Smith trigger, this is to work in a band. Hysteresis known as the hysteresis band. That's why the output is B, C, and D, any one. But this is the when the input voltage is positive, then C option is correct. When input voltage is negative, which is negative of this, then D option is correct. But I have calculated the output V in, the input of the Smith trigger is minus of V in. That's why D option is correct in that question. Okay, next is the following circuitry is used for a mathematical operation in a battery charge equalization operation. Which of the following operation is being implemented using this circuitry? Okay, op amp also there, but here is the only negative feedback. You can see this is the negative feedback, this is the negative feedback, this is the negative feedback. It means this is there is the not a Smith trigger. If negative feedback is there, then you can simply use the virtual sort method. Any other information is not given, it means this is the taken as the ideal of them. This current will be 0, this current will be 0, because in the ideal cases amplifier is have a, sorry, this is not 0, this will be 0, this will be 0. Why we have a higher impedance, infinity impedance in ideal cases. And draw again here to explain this one. This one is the negative, positive, this one negative. This is the out, negative, this one positive, another resistance is there here. So the feedback resistance, all resistance is same value, r, 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 this will be 2r, this will be r, r, also r. Okay, I am taken some assumption, this one I will take as a v. Okay, I have taken this one as the v naught 2, I will take this one as the v naught 1, I take this voltage as a va, and what will be this voltage? Okay, this is the negative feedback. Negative feedback means op-amp works like work as you can work as a virtual sort. You can take this one is the virtual sort, positive and negative terminal of the op-amp. It means this current will be 0, this current will be also 0. This current, this voltage and this voltage will be same, because of this will be in virtual sort. Virtual sort, it means this will be a same potential, at same potential. That's why you talk about the virtual sort. This is not a physical connection between the V2 and the positive terminal and negative terminal. That's why it will saying like a virtual sort only. It is not a connection between them. Virtual sort, because of the voltage voltage of a positive terminal and negative terminal will be same. Even the negative feedback is there. It means this voltage is same as V2. Same thing here also. This will current is 0. This will be 0, and this voltage is same as the V1. I taken as a V on not 2, V not 1. I will take a VA. I will take a voltage VA, and same voltage also here VA, because negative feedback here also. This current will be 0. Then what is the current flow? Where, how it will flow? This is the virtual short. Same potential. I take as a VA as a potential. Then what is the current of this one? VA by R. VA by R. This current. This current is 0. Then same current is also flow here. VA by R. This is the positive. This is a negative because of the entering current. So the resistance is positive. What is the this current? This current will not be same because of some of the current is, it can be flow here or can be supply the current open. That's why it can't be say, can't we say that this current and this current will be same. Can't we take this one also because of some of current flow in op-amp or it will be out of op-amp, anyone, anything will be there. But here is the same current. If this current is this current, it will be also same, and this current also same, but this current is not same. This is a different current. Okay, I taken this current, but this current and this current will be same. And what is this current? We can take as V output minus of VA divided by R. V output minus of VA divided by F R. This current flowing through output to is here. You can take any direction of current because I take as the VA is the input of this one. I will let this one. That's why the current is flow from here to ground because of ground terminal is here. That's why the current I will take in like this one. You can take any direction. Then what is the voltage of this one? Voltage of this one, it means same current flow here, current into resistance, V output minus of VA divided by R into R. And this, what is this current? This current, this current and this current is same. We can find from here Vt to V1. This current is V2 minus of V1 divided by F2R. This current is flowing through this one, this resistance because of V2 is there given in the question, and same as V2 is a negative terminal also because of virtual short. Then this V2, this is the V1 similarly. Then V2 minus V1 divided by 2R is the current flowing through this resistance, and same current flowing through the feedback, and same current flowing through this feedback also because of this current is 0, this current is 0. Then this here to here is the same current flow, but here is different current because of some current is here and some current is here also. And this current is the VA, V0 minus VA divided by R. This current is also same. I have written here current is V0 minus of VA divided by FR. Then take in a KVL of this one. KVL, this is the short, and take this from here to here. I will start from here. The current is flow here from in this there to there. This will be positive. This will negative. This is also positive, negative. So positive, negative also already there. Then start from here, and if you start in that point, then comes to the that point is the closed loop of the KVL inside same point. Then what is the voltage of this one? VA minus of V naught minus of VA divided by R into R is the voltage drop across this resistance. I written plus here. V output minus of VA divided by of R into R plus next resistance is here. And what is this current? This current is same as this one, V2 minus V1 divided by 2R into R. V2 minus of V1 divided by of 2R into R plus next resistance is here. This is a V2 minus of V1 divided by 2R into 2R. The voltage drop. V2 minus of V1 divided by of 2R into 2R plus next resistance. This is same current, V2 minus V1 divided by 2R into R are the voltage drop. V2 minus of V1 divided by of 2R into R plus this voltage. This current is the VA by R because of this one. VA by R plus VA by R into R. VA by R into R plus anything here? No. This is the virtual start, and this point will be same. I start from here, then here, and this one will be same because of the virtual start, and this will be closed loop of KVL equal to 0. All R or B cancel out. Then this is V naught minus of VA plus V2 minus V1 divided by of 2 plus V2 minus V1 divided by of 2 also cancel out, same. Sorry. Plus V2 minus V1 divided by of 2 plus of VA is equal to 0. VA also cancel out. This will be the half. You can add this one. This one is the V2 minus V1 only. This one V2 minus V1 also. Then both are add up. Then V naught plus 2 V2 minus of V1 is equal to 0. And what is the output voltage is? Sign will be changed to V1 minus of V2. This is the output voltage. Sorry. Oh. Okay, everyone. This question. First of all, take op-amp and find the feedback. Which one is the positive feedback or negative feedback? If there is a negative feedback, then take a virtual short. Then positive terminal voltage is same as the negative terminal voltage. And after that, then calculate the current of all of resistance flowing through resistance. Then apply a KVL. Simple voltage Kirchhoff law and equal to 0. We will get the answer. Five batteries, each of the 12 volt nominal, are connected in series. A charge pump based equalization circuit is employed. The reservoir capacitor voltage can be. A series connected battery, if many battery is connected in series, then charge equalization is a problem because of there is some chemical. This is the battery is the chemical storage. That means some chemical reaction and some elements are different. If you made at the same laboratory, same material, but some of the error is coming in all of the batteries. That's why the capacity of all battery is different. Minimum difference or maximum difference, it depends, but some of the differences also occurs between the two batteries. That's why the charge equalization is the important in series connected battery. Same thing you know about the lithium ion cell. Lithium ion battery is made by the lithium ion cells. Number of lithium ion cells are connected in series and parallel. In series connected lithium ion cells, I have a problem of the SOC differences. Then the balancing is there. There is a different type of balancing: active cell balancing, passive cell balancing. Because of the lithium ion cell, is that nominal voltage is 3.7 volt only. To make the 48 volt battery or 72 volt battery, a 96 volt battery, a 24 volt battery, a 12 volt battery, then number of cells are contained in series. Then it will charge the cells, then some of the cells are fully charged and some of cells are lesser charge, or some are not full charge, but some of the difference between them. Then if one cell is full charge, suppose the one cell is full charge, then you can't be go on the charging phenomena. You should stop the charging because of the one cell is overheated, overcharging if you not stop there. That's why the other cells are not utilized at maximum capacity. There is some problem. To avoid this one, the charge equalization is the required, and the lithium ion cell is the associative balance. There's the two types of active cell balancing and passive cell balancing. There's a cell balancing phenomena. But here is the two batteries not mentioned. Is the lithium lead acid or lithium ion battery, but it was I think asking about the lead acid only. The battery is connected. 12 volt battery is directly connected in series, like a five batteries. Then one is suppose one is full charge, and other is the not full charge. It will be some differences. Then how works the battery? Let's suppose this one 4. This one is a 5 battery. Switches are connected, and in charge pump method, a inductor and a capacitor are used. So, diode is there. The whole circuit is work in a boost mode, like a boost converter mode. There is a reservoir capacitor. Boost phenomenon also is there to charge the whole cell battery. This will V1, V2, V3, and V4, and V5. Suppose this one is the higher SOC, higher cell. Then this switch is on, turn on the switch, and this will charge is stored in the inductor. After that, switch off this one. then this inductor current will flow through the all batteries and a capacitor through the diode, this one, in that phenol, and capacitor will be charged. To discharge this one, it will be discharged through this inductor, and whole of the inductor circuit current is flowing through the whole pack, battery pack. This current is flow like that. This is a charging phenomenon. Okay, he is asking about the what is the reservoir capacitor voltage. This is the maximum voltage V 5 voltage. Then what is the total voltage? BT 5 into 12 volt allo battery. This will be the 60 volt. But this circuit is work in the boost mode or boost converter mode. And boost converter mode, this will be work like a source when the discharging condition. When discharge the charges, here this reservoir capacitor in discharge, then this resistor is work in boost mode, boost converter mode. Then this is act as a source at that time and feed the energy through the inductor to the whole battery pack. That's why the to operate in boost mode, then the input voltage of this one is this should be lesser than the whole voltages. In the maximum voltage is 60 volt, then it should be lesser than the 60 volt to work in a boost mode. If you increase the voltage like say more than 60 volt of CR, then it will not work in boost mode. A boost converter, like a boost converter. In boost converter, the input voltage is always lesser than the output voltage. That's why the reservoir capacitor voltage should be lesser than the 60 volt. This is one option is 48 volt. To transfer the energy, reserve energy through the whole battery pack, through the inductor. A lead acid battery and a lithium LiPo battery, the same lithium ion battery, lithium phosphate battery, are supposed to supply current to a common load. Then should connect in battery in series, should connect the battery in parallel, should not use battery of different types, should use charge equalization. But it is not mentioned in parallel mode or series connection or parallel connection. Then this is the should not be no, this is not an important thing. You can connect lithium ion battery and lead acid battery, but all of you know about the lead acid battery and lithium ion battery. There is the more advantage of lithium ion battery. The terminal voltage with respect to the SOC is higher than the lead acid battery. Then in that condition, if you connect in series, suppose if you connect in series, then lithium ion battery is suddenly charged. It will not more losses with respect to the lead acid battery. It will suddenly charge, but lead acid battery is not charged at that time. This is the very big differences if you use in series connection. The charge equalization is very important in that thing. This is the very big differences in the SOC if you connect this one, because of the date of discharge, depth of discharge of lead acid battery is very less with respect to the lithium ion battery. It is very quickly discharged and it can't be fully utilized of lithium ion battery. That's why it should not connect in series, but should connect in pattern in parallel. Yes, same voltage in same voltages to connect in parallel, because of this is the practical battery. Practical battery have some internal resistance, and lead acid battery have a more internal resistance with respect to the lithium ion battery. That's why you can connect to the in parallel, but same voltage rating. 12 volt battery only you can connect in parallel, but you can't be connected in series. If you connect in series, then the large differences between the SOC when charging the battery or discharging the battery. That's why you should use in parallel mode. And this is the correct. You can use in parallel connection. A 20 Ah battery with a nominal voltage of 12 volt is connected to the terminal of a PV model of charging. A PV model has a short circuit current of 2.5 ampere and open circuit voltage of 14.5 ampere. The battery has a C rate of C10. If the internal resistance of battery is zero point 0.5 ohm, the appropriate operating point will be. It will direct connect in charging mode. No, sorry. Yeah, for charging. This is a VT, IT or IV. This is RV, VV. VT is equal to VV plus of IT into RV. At battery maximum current by C rating, if it's a current of IV maximum is 20 divided by of 10 is be 2 ampere. We can't be charge the battery more than 2 ampere because of C rating. In the 2 ampere model, this is the only option 13 volt. This is also matched because of the voltage of battery is the 12 volt only. This is the 13 volt. It will be matched practically for the charging because of the terminal voltage of the solar panel is more than the battery voltage because of the resistance, internal resistance of the battery. VP is 12 volt, for IT is 2 ampere, RB is 0.5 ampere. This will be the 13 volt. Then 30 volt and 2 ampere is the option. Same thing, same questions. I think if the internal resistance of battery is zero point 0.5 ohm, then the approximate input resistance seen by the PV model. Then what is the input resistance of this one? Same thing, VT by IT. I think same. If you calculate the RT is VT by IT. VT is 13 volt, IT is 2 ampere, 6.5 ohm. This one. The duty cycle of the DC-DC converter shown in figure below is 0.4. Assume the inductor current waveform to be continuous. The charging current of the 5 volt battery under a steady state condition is. This is the buck converter. Buck converter, you all know about the output voltage is dVs. This is the output voltage, total output voltage. And Vs is 20 volt, D is 0.4, 8 volt. Then current is asking about this one, IV battery current. 8 minus of 5 divided by your internal resistance, 1 ampere. Yeah. Our photovoltaic model has open circuit voltage of 16 volt and short circuit current of 3 ampere. This model is directly connected to the battery which has a no load voltage of 12 volt. The battery is getting charged from the PV model. The most appropriate operating point. In charging condition mode, then Vt is equal to Vb plus of Ib into Rb. It should be more than Vt should be more than the Vb in charging condition. Then Vt is greater than 12 volt. Then 12 volt greater than 12 volt is a 14.5 and 30.5. But this is current rating is very less. That's why you can choose this one 30.5 and 2 ampere. Ib 2.7 ampere. Same question. The internal resistance of the battery. I have calculated Vt. I have taken as the Vt operating point is 30.5 and current rating I'll take 2.7. Vt voltage is given as 12 volt. Vt is Vb Vt voltage plus Ib into R. And what is the Rb? This is battery internal resistance. Vt minus Vb divided by f Ib. Vt 30.5 minus 12 volt divided by f 2.7. 0.55 ohm. A photovoltaic model has open circuit voltage of 16 volt and short circuit current same phenomena. It directly connect to the battery which is a no load voltage 12 volt. Both the module and the battery are supplying the power to the load of resistance of 1.6 kilo 6 ohm. This is the resistance load resistance 1.6 ohm. This is the battery IT. If you connect the battery voltage through the load, then the terminal voltage of the battery will decrease in discharging condition. It will reduce from 12 volt and less than 12 volt, and only one option is this one 9.5 volt and 2.9 volt ampere. Then this option is correct. Because of when you discharge the battery due to the internal resistance will be the lesser the terminal voltage at no load from no load. The buck converter is used to charge a battery in a current control manner. Same thing, same voltage. The buck converter is being supplied by a PV source. And the first question is same as the buck converter here, and there is the boost converter. Battery has a nominal voltage of 12 volt. The buck converter uses MOSFET semiconductor devices, which is the switch at the 50 kilohertz. The buck converter uses 4 millihenry inductor with the maximum current of 3 ampere. The slope in the current reference should be. Same question like a boost converter. This is the buck converter. This is the this is the battery. Auto resistance, battery is there. Capacitor, inductor. This is the inductor voltage. Switch, this is Vt. Terminal voltage of the PV panel. Reference point taken from the decreasing of inductor current slope. Decreasing slope occur when the switch is off, and switch is off, then what is the inductor voltage? Well, switch is off, then this is the complete the circuit from here. This is the positive terminal, negative terminal. This is the VL is equal to minus of VB. VL is L DIL by dt minus of VB, then DIL by dt is equal to minus of VB divided by FL minus of VB. VB is 12 volt. L is 4 millihenry in 10 to power minus 3. This is the minus of 3000 ampere per second. Is given in ampere per second. Same thing you can say volt per millihenry, volt per henry. Okay, everyone, I am stopping here for classes.